Next method is Vowels approximation method. This method also takes cost into account in allocation. 5 steps are involved in applying this method. Step 1. Determine the difference between the lowest two cells in all rows and columns including dummies. Step 2. Identify the row or column with the largest difference. Ties may be broken arbitrarily. Step 3. Allocate as much as possible to the lowest cost cell in the row or column with the highest difference. If two or more differences are equal, allocate as much as possible to the lowest cost cell in these rows or columns. Step 4. Stop the process if all row and columns requirements are met. If not, go to the next step. Step 5. Recalculate the differences between the two lowest cells remaining in all rows and columns. Any row and column with zero supply or demand should not be used in calculating further differences. Then go to step 2. The Vowels approximation method or VA method usually produces an optimal or near optimal starting solution. One study found that VAM yields an optimum solution in 80% of the sample problems tested. Now you can see an example. Find the solution of transportation problem using Vowels approximation method. The table is shown below. First of all, find the total number of supply constraints which is equal to 3, total number of demand constraints equal to 4. Then calculate sigma Si and sigma Dj, both are equal. This shows that the problem is a balanced transportation problem. Now from the given table, we can calculate row penalties and column penalties. Look at the first row. Here, the lowest cost is 10. Next lowest cost is 90. Take the difference. That will give you the first row penalty. Then look at the second row. Here the lowest cost is 30. Next lowest is 40. Take the difference. 40 minus 30, that's equal to 10. That's the second row penalty. Similar. Look at the third row. Here the lowest cost is 8. Next lowest is 20. The difference will give you the third row penalty. Then coming to columns. Look at the first column. Here the lowest cost is 90. Next lowest is 40. The difference is 21. That is the first column penalty. Similarly, we can calculate next penalties, column penalties corresponding to second, third, fourth columns. This is our table 1. Of these penalties, consider the largest penalty. That is, the maximum penalty is 22. That occurs in column D2. Then, in that column, select the cell with the minimum cost. Minimum cost occurs in the cell S3D2. That means we have to give the allocation to that cell S3D2. To find the allocation, as we have done in previous methods, find the minimum of the rim values. Minimum of demand and capacity, that is minimum of 8 and 18, which is equal to 8. Then the value 8 will go to the cell S3D2. Correspondingly, the rim values become 10 and then the rim value of D2 becomes 0. That means the maximum allocation in the cell S3D2 is 8. It satisfies demand of D2 and adjusts the supply of S3 from 18 to 10. That means you have to write the difference value, the rim of S3. So this is our table 2. We can strike out the column corresponding to D2. Then again calculate row penalties and column penalties with the remaining rows and columns. Look at the first row. There the least cost is 10. Next least is 19. The difference will give you the first row penalty, that's equal to 9. Then similarly second row, consider the second row, the least cost is 40, next least is 60, the difference is 20, that is the second row penalty. Then similarly third row is minimum is 20, next minimum is 40, difference is 20, that is the third row penalty. Similarly, we can calculate the column penalties. All the values are shown in this table. That is our table number 2. Then from these penalties, row and column penalties, look at the largest penalty, that is maximum penalty is 21, that occurs in column D1. In this column, select the cell with the minimum cost, that is minimum cost is in the cell S1 D1. We have to give the allocation to that cell. To find the allocation, as in the previous method, find the minimum of this demand and supply, that is 5, 7. The minimum is 5. The 5 will go to the cell S1 D1. That is the maximum allocation to the cell is 5. It satisfies the demand of D1. Adjust the supply of S1 from 7 to 2. That is the difference value we have to write in the rims. The rim of S1, the value is 2. Then the rim of D1, the value becomes 0. Then we can strike out that column. So that is our table number 3. Look at table number 3. Here strike out D1. Then again continue the procedure as in table 2 in table 3. Here only 2 rows and 3 rows and 2 columns. Again calculate the row penalties and column penalties. Of these row column penalties, find the maximum penalty. Maximum penalty is 50. Then so select the cell, select the column S3. In that row S3, select the cell with the minimum cost, that is in the cell S3 D4. Minimum cost is 20. So that select the cell S3 D4. Now we can form table 4. So from the previous table we can strike out the row corresponding to S3. Then with the remaining 2 rows and 2 columns, again continue the procedure. Find the row penalties, column penalties. Of these penalties, maximum penalty is 50, that occurs in column D4. Then find the cell with minimum cost, that is in S1 D4. Then allocate the value to that cell. So the maximum allocation cell is 2. That is, we can calculate minimum of 4 and 2. So minimum is 2. We can allocate that value to that cell. Satisfy the supply of S1 and adjust the demand of D4 from 4 to 2. Then we can form the next table corresponding to like the rim values. The rim value corresponding to S1 becomes 0. Then corresponding to D4 it becomes 2. Then strike out that row corresponding to S1. Then we can form the next table. In table 5, the maximum penalty is 60, that occurs in column D4. Then find out the cell with the minimum cost, that is S2 D4. The cost is 60. Then we have to give the allocation to that cell. So minimum of 2, 9, that is 2. That value will go to the cell S2 D4. Then change the rim values corresponding to S2 and D4. And we can form the next table. So this is our table number 6. Calculate the row penalty, column penalty. Then the maximum penalty is 40. That occurs in row S2. Then maximum allocation to be given to the cell S2 D3. So maximum allocated value is minimum 7, that is equal to 7. It satisfies supply of S2 and demand of D3. And we can form the next table. So this is our final allocation table. Write down S1, S2, S3, D1, D2, D3, D4. Then write the row penalties, column penalties. You can write like this. Then these are the allocated values. Find the minimum total transportation cost, that's equal to that we can calculate. This is our final allocation table. From this table we can calculate the minimal transportation cost, that's equal to 19 into 5 plus 10 into 2 plus 40 into 7 plus 60 into 2 plus 8 into 8 plus 20 into 10, that's equal to 779. Here the number of allocated cells is 6. It shows that solution is a non-degenerate solution.